Hi, everyone. My name is David Meyer from Databricks. I'm super excited to do this presentation with Lingzhi from Microsoft and Nicolas from Databricks on how to build your advanced AI solutions entirely on Azure Databricks. Lingzhi?
Yeah, thanks, David. Welcome, everyone. As David said, in the next 30 to 40 minutes, we're going to explain and show you how to build your own advanced AI solutions entirely on Azure Databricks. Back in the 1950s, Alan Turing came up with the famous Turing test. It's his way of figuring out if a computer could chat just like a human. Fast forward to today, and wow, has AI come a long way. It's abundantly clear that AI has the potential to transform nearly every aspect of our lives. Experiences based on large language models like ChatGPT has taken the world by the storm, and you cannot turn on news every day without someone talking about the GenAI. They're built on the vast store of data, leveraging the massive computing power available today in the cloud. Now that we've seen this technology break through with consumers, so it's not just for techie anymore. As a result, you can expect your employees to start demanding these kinds of experiences in the tools that they use each day. Similarly, your customers will quickly come to expect AI capabilities in the services you offer. AI has become a hallmark of modern service offerings. To meet and exceed evolving customer expectations, your application and solutions need to embrace and integrate AI, integrate with GenAI, generative AI. Slashdata reports that over 50% of developers have already integrated generative AI into their apps or plan to do it in the next 6 months. Gartner literally predicted this will expand to 80% by end of 2024. So as we experienced with ChatGPT, generative AI can make application truly intelligent. From constrained interactions with human to natural language interactions, from hard-coded fixed data sets to data-driven personalized experience that can improve over time, learning and adapting from the interactions, from costly and complex application changes to quickly deliver new features. So our experience creating and involving GitHub Copilot has paralleled external development team experience as they realized their own ideas for intelligent apps on our platform. Together, we actually all learned more about what's possible with AI in the last 6 months, more than that we have learned in previous decades. In the concept such like prompt engineering, embeddings, and RAG were vaguely defined a year ago. Today, they become a common topic in the daily discourse of developers and emerging cohorts of AI engineers and building intelligent apps. Yes, new job titles are emerging. Even among the very experienced teams, building an AI-powered app can still feel like equal parts of engineering and alchemy. Well, it's art, half arts. Similarly, small changes to the language or context in a prompt can lead to a large inexplicable differences in accuracy or reliability. Reproducing and fix a problem, prompt response, or customer issues can take thousands of iterations or simulations, not to mention the time. The stochastic nature of large language model interactions make testing especially important, and you want to do this online. More than ever, developers building AI applications need a platform and a tool sets for building Gen AI solutions.
Thank you, Lingzhi. So with all of this excitement, everybody wants to build Gen AI apps, LLMs, chatbots, etc. Every company wants to do it, but 90% of them don't know how. They're not confident going into production. So Azure Databricks is a full suite of tools to make this production journey straightforward and reliable. In fact, it's all based on this thing you've heard a lot about over the last 5 years of the data lakehouse. The data lakehouse is the foundation for being able to do all of this AI stuff on top of your enterprise data securely. And just recently, Azure Databricks was named as the leader in the lakehouse Forrester Wave. Now, when you take the lakehouse foundation and you add generative AI and AI things to it, we believe it fundamentally changes. Because the lakehouse was already the simplest architecture for managing data at scale across a variety of applications, and GenAI makes each piece easier, and more powerful. And we call that combination the Data Intelligence Platform, the Databricks Data Intelligence Platform on Azure. So first, let's revisit quickly what the Lakehouse is. All of your data, structured and unstructured, is in your data lake, right? ADLS, your data lake. On top of that, you have a unified governance layer, Unity Catalog. And through that, you can do SQL, you can do streaming, you can do ETL, you can do all of this, including building AI apps. And how does AI infuse through that layer? Well, once you have the data intelligence engine, it basically changes everything. So in Unity Catalog, when I create a dashboard and I name it my favorite dog breeds, and it's querying tables in my Unity Catalog, it knows whatever columns I'm selecting in those tables corresponds to David Meyer's favorite dog breeds, which isn't itself interesting. But the semantics of what you're doing in the business get mapped to the columns in the tables in your databases, which allow things like text to SQL, et cetera, afterwards, when people ask normal human questions to get data out of your lakehouse. The Delta layer becomes more intelligent as well. You don't have, of course, when you have massive data, you partition it by date and all of these things. But deep learning models can index data better than brute force partitioning. So we can start to rewrite the data based on the call volumes and the traffic coming through the Unity Catalog. As I said, all the SQL your SQL engineers and analysts are writing inform the semantics, so when people do text to SQL, it gets the right answer. Orchestration workflows are all moving to serverless, and the serverless machines are pre-warmed with ML algorithms to bind to your work as soon as you start doing it, and to do it more effectively and monitor those pipelines. You can do streaming at scale, Delta Live tables, to choose algorithms based on the data flows. All of this is informed by the semantics in Unity Catalog. So that's the core of the system. Now, once you have that system, the AI piece comes into play. Natively, within Azure Databricks, all of the pieces to build AI applications are inside the system. Anything in the Unity Catalog can be used as a feature store for training models, as a vector database to vectorize the data. And you'll see all of this in Nicolas's demo to power your RAG apps and things like that. And it's all wired into MLflow, which is the most popular full lifecycle machine learning pattern on the planet. So we have all of the ML ops within the Databricks Lakehouse, which has been there for a while, and we're adding on all of this AI capability, including a RAG database, a RAG system, a vector DB, model serving, and a plurality of models. So whether or not you want to use Azure OpenAI, Llama 3, our own DBRX, Mistral, or any of these, they're all baked in for you to fine tune with your own data and serve for your customers. And we'll see that in a demo in a second. So when you have Mosaic AI on top of this data intelligence platform, you can build AI applications with complete control over your data and the models they're serving, and the full auditing and lineage that things like responsible AI legislation are going to be mandating within about a year in certain countries. You have production quality, so you can monitor drift either from upstream schema changes in tables out to inference serving of the model. And you can do it all at dramatically lower cost of training, fine-tuning, but most importantly, lower cost of serving for these applications that you're going to unleash to millions of your own users. So you get complete control, production quality, and lower cost. And when you're building your generative AI solution, there's a variety of patterns, right? You can just start using something like Azure OpenAI and do some prompt engineering to make it have a simple chat app, but you want to bring in your own data. So you can start using the RAG pattern, retrieval augmented generation, which takes your data and feeds it as like the most important contextual information for the LLM. Or you can take an LLM like our own DBRX and fine tune it with your own data, your own code samples to build a library for your own code completion, and then serve that within Databricks. Or you can do pre-training and build your own fully bespoke model that you control and own and can use as a core of your business strategy. So this whole spectrum is available within the Mosaic AI inside the Azure Databricks Data Intelligence Platform. So designing your AI application, Lingzhi, how do we design an AI application?
Yeah, so let's get into the weeds a bit, right? What makes it different? Generative AI application added quite a few new components into your application development lifecycle. And because now you mix intermingle of the code you write to control the behavior and of the code actually generated and the behavior and output generated by a machine learning model, which you can't really prescriptively control. So it changes the few ways of how application is designed, built, and managed. First, I want to call a few things, right, on this loop of lifecycle of GenAI application. First, you need to select of the right foundational model. There's hundreds of them, and it's like the amount and the speed of this large language model come into the world it's so fast, it's dizzying fast. You can choose from OpenAI GPTs, Llama 2 and 3, any models from Hugging Face, just tons of it. And then you can fine tune all of them. You have lots of permutations of it. There's so many ways of fine tuning these models that you can combine them. So then a generated text may not always align with what a human's judgment expected it to be, or does not align with the domain-specific knowledge. So it's not easy to detect the issues and not easy to detect the bias and mitigating it. You can insert, by mitigating it, you can insert the knowledge or context into the input of the models. Of course, you can always fine tune it. And using domain-specific grounding data or enable in-context learning and use cases with specific examples. This is essentially called a RAG pattern. Retrieval Augmented Generation Pattern is the most popular GenAI application model today, pattern today. You definitely need a tooling for that. And everything's new and the process new. So you need a tooling to track and evaluating every iteration online, because it could take thousands of iterations to get it right. So you want to do this online. You want to do this real time. You want to do A/B testing online. And you want to be able to monitor the performance and metrics for the GenAI flow you build, detecting any data drifts and communicating the model's performance to your stakeholders. But at the end of the day, you want to contribute business value and from your application. So since we're talking about building applications, let's dive into the most popular GenAI application patterns. Actually, we already said multiple times, RAG, Retrieval Augmented Generation. This has become the most popular GenAI application patterns nowadays. It is a required pattern if you want to actually connect your data real time to customize a GenAI application like a customer support chatbots. And creating high quality and accurate RAGs is hard, is very hard. And just having a good foundation model is far from enough. Your system needs to be able to collect human feedback, either the clicking away, or the talking, or the texting. And then your system need to have a way to close that loop to improve your model behavior real time. And with these feedbacks to enforce the guardrails you want to implement in your chatbot. Last thing you want is have your chatbot go rogue. We had plenty of those experiences made news. So at Databricks and Azure Databricks, we believe RAG quality is a system problem. And we are here to actually building a system, and we're going to show you, actually Nicolas is going to show you, and how to actually integrate everything into the single platform and allow you to build an effective, high quality RAG systems end to end. Combine your data, make all your data interface from unstructured data pipeline to structured data pipeline, and everything will happen in real time. You will become the most effective GenAI application developer. There's so many capabilities we're going to show you, and I just want to call out vector search and a vector database is built in and in preview. So with that, and I will pass on to Nicolas to show you exactly how everything works.
Hey, Nicolas, are you ready? Are you ready to demo? Here you go.
Whoa, thanks, David. Hi, everyone. My name is Nicolas, and today I'm here to walk you through how you can build your own advanced AI solutions on Azure Databricks. So let's go ahead and jump into the demo. And the first thing that we're going to show is the AI Playground. So the AI Playground is a really awesome way to get a feel for how different foundation models might answer specific prompts. It lets you test things like token throughput, lets you tweak hyperparameters, and it really gives you a good starting feel for what base model you might want to use to build your AI solution on top of. In this case, you'll see that we have DBRX instruct on the left. We've got 𝗦𝗲𝗀𝗀𝗶𝗀𝗀𝗀𝗀 chat on the right. We can actually add or remove models as well, but let's just look at 2 for now. You'll see we've got these kind of sample instructions. So let's just see what they look like when you do summarization. Right now we can get a feel for things like tokens per second, time to first token. And if we want, we can also tweak different hyperparameters like temperature, top P, max tokens, etc. All of these models that you're looking at here are actually provided already for you through the Foundation Model API. So these will be available to you right at the first time you jump into a workspace. So you don't have to go and assign GPU resources and all of that. So today, we're not talking about just prompting base models, though. We want to show you how you can build a more advanced AI solution that understands and is able to reference your company or your group or your enterprise's data to give you much higher quality responses. So to drive that point home, what we're going to do is we're going to take a bunch of research papers and we're actually going to process them. We're going to put them in a vector search index. We're going to tie them to a base model. We're going to create a retriever so that your now AI system can take the question that you ask it and go retrieve information relevant to your question and ultimately give you a much higher quality response. So for this first example, let's look at this research paper that was written by 𝗦𝗽𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀, which is our CTO, amongst other people from Stanford. This was released very recently. I want to say 4 or 5 months ago. This latest 31 March is a revision. Now, the important part here is that this information was not available to our model when it was trained, right? So it doesn't have any knowledge of this. Now, let's go prove that to ourselves, right? If we go back into our AI playground, and we can even ask a couple models just to drive the point home. Let's say, what is 𝗬𝗲𝗄𝗏? You'll see that it gives us 2 answers. And neither one of them are what we would consider a high quality response, because we would like it to tell us that 𝗬𝗲𝗄𝗏 is actually an automated evaluation framework for retrieval augmented generation systems. Whereas both of the models here are kind of quoting other things that they may or may not be true, but they are not a high quality response for our case. So let's go and see how we can improve that. So first, we're going to jump into Unity Catalog. Now, I'm going to take a moment to pause here because Unity Catalog is actually very important to a lot of different things that are going to go on here. So first of all, Unity Catalog is a way where you can govern not just your data. So here you have 5 tables, but also your file storage. So we've got a Unity Catalog volume here. This is actually where we're going to load all of our PDFs and models and even functions if you have them. Now, the reason that's super important is because it gives you one centralized place to govern your data and your AI assets. So you can set permissions to all of these things in one place, which makes your life as someone that has to organize these complex AI systems much simpler. Now, let's go back to this Unity Catalog volume. If we go to this PDF landing volume, you'll see that we have 6 or 7 PDFs that we've uploaded, 8 of them. And these are all different research papers. And what we've done is we've processed those into tables. Now, we're not going to cover that part, but we're just going to look at the end result. So if we go to this gold PDF landing chunked table and we go to sample data, you'll see that this has all of the textual information from our research papers in this table. Just a little bonus of Unity Catalog too. You can actually go to lineage and you can see the graph. You can see where all this data came from. So if you need to do a root cause, you need to understand your system a little better, right? You can see, okay, this is where my data came from. This is how it was transformed. This is where it ended up. So now that we've got our data in this nice chunked table, we need to turn it into a form that we can chain it into our model and that our model can retrieve the relative information when we ask it a question. To do that, we're going to create a vector search index. Fortunately, this is super easy to do on Azure Databricks. We just go on the top right, we hit create, go to vector search index. We're going to give it a name, PDF, gold index. We're going to give it a primary key. We've created an ID for it. Now we have to give it an endpoint. Again, we've created a vector search endpoint, super easy. We're going to tell it we'd like it to compute embeddings for us. The column that we'd like it to embed is the chunked text column. And now we have to choose an embedding model. Now you can see that through model serving, if you wanted to use a third-party model, an external model, that's not a problem at all. However, in this case, through the Foundation Model API, we actually do already host BGE large for you, which is super easy. So we can just use that one. And now we have sync mode. So here we can choose if we want to update this vector search index on a triggered mode. So if you have, say, data that only comes through once a day, once a week, you can save resources by triggering that at a specific cadence. Or if this represents data that comes through a lot more continuously, then you might want to dedicate resources to always keeping the vector search index up to date with the latest and greatest. Now, we're not going to create one now. We've actually just already done that. So if we go back to our catalog, again, right next to our data, we have our gold index. And now we can go and look, and this kind of shows you the different things that our vector search index is comprised of. So what the source table is, what the serving endpoint is, and what embedding model is being used, and the last time that it was synced. So now let's jump into a notebook and see how we can tie this vector search index into a foundation model and create a RAG chain that gives us a much higher quality response. So we're going to kind of skip through the boring stuff, the import of libraries, and let's start right here. So what we're doing in this little block of code is we're just setting up the retriever, and we're basically just telling it, look, this is the name of the endpoint that we would like you to use. This is the name of the vector search index. So when your model goes and asks a question, it knows I need to go to this index, and this is how I access it. Just one block of code, not horribly complicated. Now we have to define our model. So in this case, we're using DBRX instruct. We're just going to give it a max token size. And just to prove that it's working, let's run the cell. We're going to ask it the same question we asked earlier. What is ARES, right? In this case, it told us that ARES is the Atmospheric Remote Sensing Infrared Exoplanet Large Survey, a planned space telescope by NASA. Remember that we would like it to tell us that ARES is actually an automated evaluation framework for RAG systems, right? So not a high quality response from what we're looking for. So now let's test the retrieval. So we're going to say the same question, what is ARES? And we're going to actually feed it to the retriever we set up. And what that's going to do is it's going to go look in our vector search index, and it's going to pull back the closest related data that it can find, right? And this is just the text from our research papers. Now, this is important because what we're going to do in the next step is we're going to tie these things together. So what you're looking at here is a prompt, a template that is going to say, you are a helpful assistant designed to help answer questions related to research topics. Please review the information below. And here is where we're going to feed in that context of everything that comes back from our vector search index from that retriever. We're going to put here as context so that the model now can reference all of this information to give you a better answer. And then we're going to tell it, please provide a detailed, accurate response, incorporate the references, please ensure the answer is informative, provide any links to references used. And then we're going to tell it the question that we're going to ask it. This is going to be what is ARES, or whatever other question we'd like to propose. And then it's going to give us back an answer. So all we're going to do is we're going to create a chain out of this template, out of the model that we defined, and out of the retriever that we defined. So let's run that. And now that we've got this chain, we're going to ask it the same question. What is ARES? So let's go ahead and run that. And now you'll see that the answer is ARES, which stands for Automated RAG Evaluation System, is an automated evaluation framework for RAG systems. It was introduced in a paper by the authors in 2023. It evaluates RAG systems, et cetera, et cetera. And look at that. It's even given us a reference that we can go and look back to make sure that everything is telling us is actually true. To me, this is a much higher quality response than we had with just the base model itself. But this is still not the end of our journey. We have this working in a notebook, but we need to create an AI application, right? So we need to be able to serve this model out to a third party via an API and be able to actually build on top of this. So what we're going to do is we're going to take this chain and we're going to register it using MLflow into our Unity catalog. So if we just run this block, we're telling it, hey, use Unity catalog. This is the name of our model. It's going to use MLflow to actually log this chain. If we open up our experiments over here, we can look at this model run. This tells us a bunch of different metadata about what happened, what data was used, etc. And it tells us that we have registered version 7 of this model. And again, if we go here, you'll see that we are now in our Unity catalog again, right? So if we go over here to models, we have PDF RAG model, and you'll see version 7. This is the one that we just created. So now let's talk just really quickly about these aliases. Version 1 was the first version, and we're calling this the champion model because we're saying that this one was the tried and true one. It's been in production for a little while, so we know that one works. We just trained version 7. So let's go ahead and delete this. And let's say that version 7 is now our new challenger model. So let's go ahead and alias that. This just lets us keep track better of, as people develop these AI systems, kind of what's going on, what the latest and greatest is. And now on the top right, you'll see this button that says serve this model. Let's go ahead and click that. This is going to take us to Databricks model serving. So what Azure Databricks model serving does is lets us expose our model via an API so that we can build applications on top of it. So we're going to give it a name, and we're going to tell it this is the model that we would like. We'd like version 7. In this case, because we don't have the model hosted specifically in the sense that we are using the foundation model API to access DBRX, we can actually get away using just a CPU compute. However, if you have a fine-tuned or pre-trained model, you can actually also assign GPU resources. We can scale it to 0. So if this is going to be kind of an intermittent use thing and would like to save costs on resources, we can let it scale down to 0. If you'd rather have something that is super high availability, you can actually disable that as well. And here's one of the really awesome things about model serving. We can add a served entity here, right? And if we go ahead and pick this same model, so go to our catalog, we're going to pick the same model. This is something that I think is just really cool. We can say, hey, I would like to traffic split, and I would like to send 80% of my traffic through the version of the model that I know works very well because it's been in production for a couple of weeks. And I'd like to send just 20% of my traffic through the latest version of my model so that I can make sure that it's going to perform at a higher quality than my original model. So what this really means for you as a developer or a builder is that you don't have to worry about downstream code because this all happens at the API level. So your outward-facing API stays exactly the same. This lets you A/B test without changing a whole bunch of code downstream. Very, very useful. Another really useful thing, if you are somebody that is building or maintaining these AI systems, is inference tables. So if you enable inference tables, what this allows you to do is it allows you to define a table where all of your payloads will be logged, right? So what that means is that every time somebody is hitting these models, the request and the response gets saved to a table automatically so that you can start using that to fine tune or to build maybe a training data set for a better model down the line. It also helps you debug in case you're not sure how things are working in production. Now you have a constant log. So we've already created one. I'll just go show you what that actually looks like. If we go to PDF RAG endpoint, you'll see that we have 2 models. We've got traffic split 2080 between the 2. We can actually query this endpoint. So you'll see it loads us up with the example that we used while we were creating it. What is Aries? We can send that request out. Oh, there we go. Awesome. There's our answer. So an important part here is that not only can we easily access it through the UI and test to make sure that it's working, but here's where we can actually get the code snippets to embed this API into whatever third-party applications you would like to build on top of it. So hopefully now you have a better idea of how you can build your own advanced AI solutions on Azure Databricks. And with that, back to you, David.
Oh, thank you so much, Nicolas. That was fantastic. I love all of the detail. Let's talk about a couple pieces that we just didn't have time to cover in the demo. So once you have these, data moving through these pipelines to the model and these inference tables that Nicolas showed you, you can monitor outliers across the whole system. As Nicolas explained, Unity Catalog automatically captures all of the lineage between your tables. So if you have schema drift in an upstream table, it can tell you all of the models that impacts, and kind of the blast radius of any error in an upstream table. And you can proactively mitigate and roll back those changes. So lakehouse monitoring is a key part of doing this with quality. I also want to spend just a couple minutes talking about DBRX and why we did it. DBRX is a model that Databricks produced using the Databricks data intelligence platform. We acquired 𝗦𝗽𝗲𝗸𝗀, and now this whole part of Azure Databricks is called the Mosaic AI part of the system. And that team has pioneered ways to train and fine-tune models at a much lower cost, but also to run them at a much lower cost. So DBRX is one of the best open source models in the world. It's the winner in a lot of categories. You can run it for a much lower cost than comparable models. And that's important for you because you might choose to pre-train your own model for your own business. You can use DBRX as a base of that, or you can just do a brand new model. But you can use DBRX and fine-tune it with your own data and commercially use it. So DBRX is a proof point of what you can do with this platform for anything in that spectrum we talked about. And I think you'll get a lot of utility out of it. But again, we want you to use any model. Whichever model, as Lingzhi said, best suits your business needs, use that model. DBRX is a very viable, exciting one that you can probably use for many use cases with the lowest cost profile of any of them. And again, with complete commercial control. So with all of these things we've talked about, we just want you to get started. You go into Azure, one click, you're in Azure Databricks, and you can use everything we showed today. And you should start building your AI enterprise applications using these techniques right away. Thank you so much for your time. Thank you, Lingzhi. Thank you, Nicolas. And have a great rest of Build.
Thanks, everyone. Thanks, David. Thanks, Nicolas.